the final 100. SETI's last hunt for extraterrestrial signals for over 2 decades, the search for extraterrestrial intelligence, SETI, has pursued one of the most ambitious citizen science projects in history. Now, that effort is nearing its end. Astronomers are meticulously re-examining the last 100 signals from a database of 12 billion candidate transmissions originally detected by the SETI at Home project. The question remains, could one of these faint echoes be a genuine message from an alien civilization? From millions of volunteers to a final few signals, the SETI at Home project, active from 1999 to 2020, harnessed the collective processing power of millions of volunteers worldwide. Participants downloaded software that analyzed data from the now-collapsed Arecibo Observatory in Puerto Rico, sifting through radio waves for unusual narrowband signals. These signals brief, focused bursts of energy were potential indicators of artificial origin. Over time, this massive data sweep yielded 12 billion candidate transmissions. The process of winnowing them down has been painstaking. Initial algorithmic filtering reduced the pool to 1 million, then 1,000. A final manual review narrowed the list to just 100 signals that warrant a second look, now being re-examined using China's 500-meter aperture spherical telescope. FAST. Why this matters? The evolution of SETI, the persistence of this effort, highlights a fundamental challenge in SETI: distinguishing between genuine extraterrestrial signals and terrestrial radio frequency interference, RFI. The project's longevity underscores the dedication of scientists who believe that even faint, anomalous signals deserve thorough investigation. The collapse of Arecibo made FAST the only telescope with the capacity to follow up on these candidates, making this phase of the search crucial. Lessons learned from 2 decades of listening the SETI at Home project wasn't just about finding aliens. It was a test of how to analyze massive data sets. Early on, the team lacked a clear strategy for scrutinizing the detections. By 2016, they had developed better filtering techniques, and by 2025, they were in the final stages of analysis. The project's success in engaging millions of volunteers proves the public interest in extraterrestrial life. Despite the scale, researchers acknowledge that many potential signals might have been overlooked due to outdated computing power in the early 2000s. There is a possibility that a real signal was missed due to limitations in the original analysis methods. We have to do a better job of measuring what we're excluding. Are we throwing out the baby with the bathwater? I don't think we know for most SETI searches, said Eric Corpella, co-founder of SETI at Home. What's next? Even if these final 100 signals turn out to be RFI, the SETI at Home project will have set a new benchmark for sensitivity. The team's conclusion is clear. If extraterrestrial signals exist above a certain power, they would have been detected. However, the possibility remains that a faint signal was missed due to early computational constraints. Scientists suggest that reanalyzing the old data with modern machine learning could yield new insights and a fresh chance at discovery. The final verdict remains unknown, but the legacy of SETI at Home is secure. The project has demonstrated the power of citizen science, the importance of thorough data analysis, and the enduring human quest to answer one of the universe's greatest mysteries.